Good day, everyone. Thank you for joining me today in this webinar by ClickPix. Today, I'm gonna basically be talking about the fourth generation enterprise data platform, the data mesh. In this session today, we're gonna first do a quick introduction so that you get to know where data mesh was born. Then we're gonna be talking about the past and current enterprise data platforms. Following, we will discuss the underlying limitations in these past generations of the data platforms, in the existing ones and in the past ones. We're going to then be talking about the fourth generation enterprise data platform, which is the data mesh. Then we're going to be covering some key concepts of basically that make a data mesh, the domain, data product, the self-serve data platform, and the federated computational governance. And finally, a few concluding slides. Okay. In this session today, I am basically introducing data mesh. It's not something that has been there for a long. It was created quite recently in May 2019 by Zhamak Dehghani. She is a principal consultant at ThoughtWorks. And basically, she published a first article in May, and then a bit later, roughly 1.5 years later, she published a second blog article. I'm not reinventing the wheel in explaining what data mesh is. Basically, in this session, most of the stuff I'm talking about is basically extracts from these two articles, because I think the way that she describes the data mesh in those articles is just excellent. And what I'm doing here is basically just reviewing these articles, explaining them, of course, I give a bit my view about what it means and how to understand it. But you will see that most of the extracts, most of the snapshots that I use are basically from her papers. So of course, if you want to go and check out the original content, that is highly advisable, and it's the source of the material I'm presenting here. What Zhamak basically suggests or proposes is a shift from a centralized paradigm that we have been using until now, and that we find in data lakes and data warehouse, to a completely distributed data architecture. We will, cover this later on. The key concepts that support the idea of data mesh are domain and the domain-driven design, data products, basically treating data assets as products, and the interesting concepts of the self-serve data infrastructure and the federated computational governance that we will be talking in the final chapters of the session. So let's now move to the generations that we have seen so far when organizations have been building enterprise data platforms. We can say that the first generation, it's basically the one that we find enterprise data warehouse and BI platforms. That is something that we've pretty much every organization wanting to do analytics before the 2010s, 2010, that was the way to do it. The main pain points that this first generation of enterprise data platform had is that they were very expensive, and organizations eventually ended up with thousands of ETL jobs, tables, and reports, and in the end, only a very small team or group of people that could manage all these things. And of course, this is in the era of the pre-big data era. So that is the major bottleneck. The big data bottleneck was the driving force that moved organizations to the second generation. The second generation is basically the introduction of the whole big data ecosystem, with the data lake as a silver bullet for everything. The pain points, as we in ClickPix have suffered together with our customers and still suffer nowadays, is the complexity of managing such big data ecosystems. Started with a data lake, then the data lake with an enterprise data warehouse, then you may add also a visualization engine, and so on. And the thing gets more and more complicated. The second generation traditionally was focusing on, let's say, the batch processing of data, batch pipelines, and still required a centralized and hyper specialized team of data engineers that were in charge of all the pipelines and data warehouse provisioning, let's say, of the organization. And in the second generation, there was no real time. It was really much oriented to batch. The third generation is quite similar to the second one, and it introduces a few concepts. No, first, the concept that we have been hearing for the last couple of years, which is the concept of the data lake house. Okay, which is pretty much a simplification of going from a two-tier architecture where we had the coupled data lake and enterprise data warehouse to a single architecture where these things or the capabilities to provide this the same that we had before with two. Now it's into one. No? The third generation also adds real-time data availability throughout CAP architectures and technologies like Flink that unify batch and streaming processing. Finally, it also fully embraces cloud-based managed services for the whole thing. And in the cloud, since many of the administrative tasks are taken care by the cloud, that simplifies a lot the pain of managing. It also reduces costs, not only because the management is done by someone else, no, because you have to spend less time fighting to debug issues and stuff like this. But still, the first, second, or third generation, they still carry over a lot of the limitations of the previous generations. And Zhamak, in her first blog article, did an excellent job at listing these limitations, and this is basically what I'm presenting here as well. So basically, the first limitation is that these platforms are centralized and monolithic. Okay, their goal is basically to ingest data from all the corners of the enterprise to enrich this data, transform it, and basically make it ready and transported so that this same data can be, or the transformed data can be served to multiple consumers with their different use cases, some for BI purposes, like reports in Tableau or Power BI, or for the feeding of machine learning use cases like a recommendation engine. Basically, this central big data platform or data platform hosts and owns all the data that logically belongs to different domains or different functional areas of the company or different, organizational capabilities of a company. No, but let's call them domain because that's the term that we will be using from now on. No, so all these domains are hosted and their data is located in a single platform, and this platform, the ownership is also by the platform team. Okay. I think I've been preparing the terrain for this. No, this model fails whenever we have a lot of domains and a lot of sources and a lot of use cases, therefore consumers. No, two pressure points that we can highlight. The first one is that the more data becomes available, the ability to consume it all and put it all in the same system under one control of one team, this starts to be quite tricky. And this totally crashes with the second point, the second pressure point, which is that normally organizations, they want things for yesterday. They want to, they think of a use case and they want to experiment with this use case as fast as possible. No? And because everything is, bottlenecked through this central data platform, then the response times, they are slower than what everyone would like, and that is a friction point that remains to be in basically all the organizations. And if you were thinking about a solution, no, the solution should not be to have fragmented data-oriented data silos that are completely dependent from each other. That's not the solution that we are proposing here. The second underlying limitation, it's basically the architectural decomposition in the pipelines that process the data. No, everything goes to an ingestion phase, then to a processing phase, and then to a serving or modeling phase. No, and we can provide some level of scale by having different teams that focus to the different areas. No, so you can have the team that does the ingestion, the team that does the Spark jobs or the transformations, and then you have the team that focuses on the data warehouse that do the modeling and all these things. But whenever you want to do a new use case, a new pipeline, basically you need to involve 3 different teams that may have different other duties, and it basically ends up being a slow delivery. The third point is the siloed and hyper-specialized ownership. Basically, you have on the one side the domain that have the data, okay? And then you have on the other side probably the same domain, maybe even sometimes the same users, sometimes different users, but those are the users that want to consume the data for analytical purposes. And in the middle, you have these hyper-specialized data engineers that handle all this. So there is this disconnection between teams because you put some guys in the middle that really don't know much about what these two guys on the other side of the wall want. You have frustrated consumers because they need to fight for the time of this data platform, because it's not only to this domain. No, you have all the other domains that want to get time and effort from the platform engineers, and that again, no, like we said in the beginning, this may work for small companies or with a small footprint of data, but as data grows and use cases grow, this will become a bottleneck. So this is the moment to introduce the data mesh. Data mesh, we could, because we presented the first, second, and third generation, it's just natural to call data mesh the fourth generation enterprise data platform. But it comes with a quite serious paradigm shift. First, second, and third, they were quite similar. They were adding little thingies, no? But this is a different, but not different, because in the end, as I will say, we will be able to reuse, luckily, many of the technologies that we have been using until now. We will just have to use them differently. I like a lot how Zhamak explains this in her first blog. She defines these 4 pieces. It's like basically the mesh is the convergence of data with 3 very solid pillars. No, one is the distributed domain-driven architecture. The second one is the self-serve platform infrastructure, or the design of it first, and third, the product thinking, the data as a product. Okay, so let's see these convergences. Okay, first, let's talk about the convergence between data and distributed domain-driven architecture. So the key idea is to decentralize our monolithic data platforms. And for that, we need to think differently about data, its ownership, and where it is located. Now, instead of flowing all the data from the different domains into a central data lake, the idea is that domains, they host and they serve their domain data sets. And they have to do it, of course, in an easy, consumable, and very important, interoperable way. The location, the physical location, could still be a centralized location, a data lake, a bucket in S3, or something else. But the ownership of the data, of this data set, domain data set, we call it for now, stays with the domain. Okay. In order to avoid duplicating processes, we also need to change a bit our thinking from push and ingest, which is what we had in the ETLs, to more a pull and serve model, so that domains can communicate and use their different data sets. When we talk about domains, there will be domains that will naturally align more with source systems. Those are the data sets that basically represent facts of the business and lie very tightly with the operational system. No? Ideally, this operational system or the functional area and its team should not only be responsible of providing the business operational capability, but it should also be responsible of providing the truth for data analytics, the truth of the data that they handle. Normally, you would find we try to separate the 2 types of data that we would like. We would have real-time or domain events, that get the data as closest to reality and to the present time as possible. And then we would have also historical and aggregated snapshots. The first one could be in the shape of a topic in Kafka or in some streaming platform. The second one could be a table or a bunch of files in some data lake. Basically, it's still a good idea to separate the data analytics from the operational system. So the underlying storage that we would have still would be separated from the operational system, and it usually ends up in a big data-ish storage, like a data lake on S3. Zamak, for her first blog article, and I think also for the second one, she's using as an example a music streaming company. Okay, so the snapshots that you would see basically refer to examples of a company that like, for example, Spotify. Some other domains, they align closely to consumption. Those are the domains that basically they aim to satisfy a bunch of use cases, like, for example, recommending my next song, in a music streaming service. These domains and the data sets in these domains that are aligned to consumption, they have different nature to the ones of the source domains. They go through many changes. They transform usually data from domain, from sources, from domains that are aligned with sources, and maybe from other, from a bunch of them. And ideally, all the data comes from other data sets from other domains, and you could regenerate the whole thing if needed. And which is good. If at some point you need a new use case, you could have a new domain and historically feed and in one day have all the historical data of one domain, because it's dependent on existing domains. Now about the data pipelines, the things in charge of transforming the data. Now these data pipelines are no longer something centralized in the central big data platform. Those are, let's call them, internal complexities of each domain, and they have to be implemented within each domain, and they are handled and owned by each domain. Of course, when we are talking about a source domain, such data pipelines will include cleansing, deduplicating, enriching of the domain events, or probably of the operational systems data. As part of the governance and the interoperability, each domain data set must also establish some service level objectives in regards to quality. And this should be something that is measurable and it can be queryable. So someone can at any moment in time ask about the quality of certain data sets of certain domain. If we now look at the domains that are closer to consumption, in those, we will also find their data pipelines, and they also need to be handled by themselves. And probably the aggregation stages that we used to find in the centralized pipeline at the end of the ETL, now there will be implementation details inside of these consuming domains. Okay, after covering the first conversions, now let's talk about the convergence between data and product thinking. The key idea is basically in order to basically introduce the concept of data product. Okay, the key idea again is to apply product thinking to their data sets. So now data assets need to be considered as a product with all the implications of that. And the organizations, data scientists, machine learnings, and BI analysts or whatever, those guys are consumers or customers of these products. Okay. We will cover the data product later, but at this point, data product, I want to say that it has to be something that is discoverable, addressable, trustworthy, self-describing, interoperable, and secure. By discoverable, we mean basically that there is a common data catalog. By addressable and interoperable, we mean that there have to be common data access mechanisms governed somehow by some body that makes sure that everyone uses the same, or that there is a global interoperability and standardization. Trustworthy, because there has to be some service level objectives regarding quality, and ideally also lineage and provenance, so we know where data originated. Self-describing, because there has to be some mechanism to provide self-describing semantics and syntax of data products. And finally, secure, because we are doing this as organization level, we need capabilities of authentication and authorization, and role-based access controls are usually the way to go here. Okay, the introduction of domains and data as products also requires definition of new roles inside the domains, and at least a couple of them. There may be others, but at least a couple of them. One, and probably the most important, is the data product owner. That is the person that owns the vision and roadmap of the data products, or a single data product, or a bunch of data products. And he or she are very worried about the satisfaction of the consumers of the data products, and they are constantly trying to improve and make the consumers happy, basically. They are the ones in charge of designing success criteria and what it takes for a data product to be good or bad, or what is how do they find the quality and implement this. The actual implementation, of course, is done by the data engineers, the data product engineers, or the data product developers. Those guys are very strong in software engineering practices, so they do stuff with CI/CD and automated testing. They also are pretty decent, but not super experts on data engineering and tooling. We will cover why they don't need to be super experts. And they are domain competent, so they know about the data they are managing, what it is used for, and where it comes from. The last conversions that we're going to cover is the one between data and self-serve platform design. Okay, the key idea here is to build a common self-service data infrastructure as a platform. That basically, you have a bunch of data infrastructure engineers or a team that owns and provides all the necessary technology that the rest of domain developers and owners need in order to develop their things, their data pipelines, and to create and serve their data products. This data infrastructure as a platform is a domain agnostic platform, and probably under the hood there are a set of different technologies to serve the capabilities that are required. You will find here things like Kafka and giving Kafka topics as a service, or having a Spark and giving the ability to run a Spark job as a service, and so on. A couple of key points about the data infrastructure as a platform. As I said, they have to be domain agnostic. They should not include any domain-specific business logic, and they have really to keep it agnostic. And the second point is that this data infrastructure as a platform is a good one if it really hides all the underlying complexity of all the systems that may be under the hood, because inside this gray box, the complexity can be, or the amount of different components can be quite daunting. And the magic here is to be able to provide it in a way that users or these data engineers that are going to do the actual work, the delivery of data products, they can do it in the most agile manner. Okay, things that we ask to this data infrastructure as a platform, the self-service, is the capability to serve polyglot big data storage. What polyglot means is that a data product can take different shapes. It can be a Kafka topic, or it can be a bunch of tables in a database, or a table in a database, more precisely, or it can be a folder full of raw files in a data lake, or a bucket in S3. No? We also ask encryption at rest and in transit. The development of such data products in this data platform, it needs to be version with version control, automated testing, continuous CI/CD, and it needs to be able to define schema and have also a catalog registration and features like this. It needs to have a unified way of controlling access with what we call the role-based access control and logging capabilities. Of course, it needs to have the capability to implement and orchestrate jobs, the data pipeline jobs, and the easier the better. And then we will also find ideally data governance and data observability capabilities with lineage, monitoring, and quality capabilities to store and talk about the quality of a data product. And then we can also talk about in-memory data caching for accessing the data in the best and the most efficient manner. And because probably we're going to have under the hood many different systems, if we can have a federated identity management with single sign-on, users will be happier, no? If they don't have to be providing users and passwords all the time for their interaction with the system. Okay, this is a summary of the first article of Zamac, and it's basically putting everything that we discussed together in one picture. Now we have the data infrastructure as a platform, we have the different domains using this data infrastructure as a platform capabilities, and the whole thing is governed by a body that ensures interoperability, standards, and so on. Okay, now the material I'm going to discuss is extracted from the second block of Zamac, and it goes a bit more in detail into the architectural composition of a data mesh. Still, it doesn't go into what technologies are good for. Still keep it very, very technology agnostic, but it goes a bit more into the into the bones of a data mesh. And it defines data product as the architectural quantum. That is the minimal unit of the architecture, what we call a node in the mesh, no? That we can deploy independently and with high functional capabilities. No? So a data mesh is not a data mesh until it has its first domain and its first data product. And but with one, it's already a data mesh, a very small and a simple one, but it's a starting point. No? A data product will contain basically three things. It will contain code, the data, and infrastructure. Three types of code. Code for developing the data pipelines that process the data. Code for providing the APIs to provide access to data, semantic, metadata, observability metrics, and other metadata. And C, code or the capabilities to ensure access control, compliance, provenance, and so on. Data, as we discussed, it can be polyglot form. It can be batch files, tables, graphs, even depending on the type of data or the data product that there is. And of course, data also includes the metadata, the semantics, the schema definition, and quality metrics, and so on. And finally, of course, the infrastructure is the machinery to run the code and to provide the compute to run the code, and the storage and the access capabilities. Okay, this is a simplification of a data product. In a data product, we will have input ports. That is the data that we will create, that we will use to create our data product. And this data is basically data that comes from the output ports of other data products. It can come from operational systems or from other sources. This data goes into a bunch of code, no? The data ingestion and transformation pipelines. And those can be batch or streaming, and these guys basically are the ones transforming the data. The transformed data gets stored into the gray area, no? The data, and that can be again a table, a topic, or something like that, no? And that of course goes in on top of that, goes into an actual infrastructure, no? So we can here see the three colors with the three sections: the code, metadata, and infrastructure. In the code, as we said, we also put the APIs to get the data about observability, metadata, all these kind of APIs, and then we had the third type, which was the data access APIs. And here we put a fourth box, which is the other process. Sorry, the other processes that may be there. Maybe there is a provenance, a compliance mechanism there that is for GDPR or for data quality process, and so on. Okay, we could merge this into the data ingestion and transformation, and then you would have the three things. Whatever you do, the data access APIs, their function is to enable the output data ports, which are basically the access to the SQL table or a view or a row, bunch of raw files, and that's basically, this is the definition of a data product in a schematic way. Here, if we try to zoom out a bit, we would find our data product, which has output data ports and input data ports. The input data ports probably come from an operational system that can be running in a microservice architecture, on a legacy application, and so on. And here in this graph, Zamac explains us that, with an O, we define an operational capability. That's an operational responsibility that this domain has. And with D, is kind of a analytical data responsibility or capability. No? So you have the O, which is operational things that this domain does, and the Ds are the data analytics, the analytical part that this domain provides. No? And you would have both capabilities being provided by the domain. Here you would have the interaction between different domains and different data products. In the example of the streaming, music streaming company, you would have the user's domain having the operational capabilities to register users, like we see here, or the operational capability that to onboard an artist in the artist domain. And then, for example, in the artists, you would have, for example, as part of the artist history data product that we would find inside here, one of the input ports probably comes from the daily streams by artist. And then here you have all the different communications, or the probably to create a playlist for a user, which is an analytical capability. As input port, you will require the profile of the user, because you will have inside here a machine learning transformation that will create a playlist for you. And this is a way to understand how these domains and data products interact between themselves. Here we go a bit into detail, an example, of various examples of these interactions, but I think I already covered a couple of examples before. Okay. The second article of Zhamak also goes a bit in detail into the self-serve data platform and defines this multi-plane data platform. This graph, at least to me, the first time I look at it, it was a bit confusing, but let's try to dissect it a bit, okay? It basically mentions that there are 3 planes or 3 dimensions when we think about this self-serve data platform. The first dimension or plane is the data infrastructure plane. That basically is the chunk of the self-serve data platform that is in charge of providing the capabilities for having big data storage in whatever form that we want. It creates the capabilities or provides the capabilities for the data transformation orchestration, for the access control, the networking, CI/CD capabilities. Okay, and this is what you find in this first plane. And this normally is managed, this plane is managed by the central data infrastructure team. And it's their responsibility to provide these capabilities. Once these capabilities are provided, then you have the second plane or dimension, which is the plane in which the developers, the domain data product developers, will do their work. In this domain and using the infrastructure plane, these guys are capable of creating a data product, reading a data product, processing a data product, creating the version control, the different versions of the processing done to a data product, and they also are able to secure the access to data product and so on. The third plane is the governance or supervision plane. That is the higher level plane in which we are able, or the governance body is capable to create the catalog or discover and explore data products, ensure that there are no misusages or duplication of entities inside the data products. It defines and secures the whole thing. Okay, and it's basically those are the 3 planes. I hope now with the explanation it's a bit more clear. In the second article, Zhamak also talks about the Federation computational governance, which is it's basically a bit of zooming to what we already discussed from the first article. Basically, the idea is to create a body, a Federated computational governance body, and this body is going to be formed by members of the domains. Different domains will send their representative, and also people from the platform team and other important people. And these guys are basically in charge of decisions that affect the whole system. Okay, they are going to be defining standards, they're going to be defining access mechanisms and so on at a higher level. And then the idea is to push all these decisions down to the infra and to the development phase. Okay, here we zoom in a bit more, but basically it's the same thing. So they standardize or define how semantics and syntax are defined, how metadata should be handled, what are the boundaries, and make sure that we don't duplicate things, and so on. Okay. If we talk about, I like this table from Zhamak a lot. I don't think I need to go into detail. Just check the blog, and this table is just a snapshot of the blog. it talks about the difference between data governance before and after data mesh. The idea is that in the data mesh, we discuss is a federated team, but they're still in charge of defining data quality, what is the data quality at a higher level, and defining other type of things at a higher level. But it's not much difference. It's just that the way to do it is a bit different. Okay, let's start with the conclusion. This is the summary of the second blog article. Basically, you see that I'm reusing some of the slides pictures there. Well, basically, the summary picture is the one from Zamac. And if we want to conclude the data mesh, the data mesh is a new paradigm. It's a practice. It's not only something that needs to happen to the entire organization. Until now, we saw that it is completely technology agnostic, and data mesh has the 4 pillars that we discussed. It is domain oriented. It is treating the data as a product. It is based on providing the self-serve data infrastructure as a platform, and it does it with a federated governance to ensure that all these things can be handled in a good way. Okay, I wanted to close this webinar with a couple of slides. The first one, those are slides, let's say, from me. So this is a bit my discussion on the topic. Here in the last year and a half, there are some of these words that we have been hearing. At least I have been seeing in different tech vendors and different blogs. Data mesh, data lakehouse, data ops or DevOps, data governance, and data observability, and all these things are together, and they are in a lot of blogs and a lot of discussion. So I wanted to make a bit the discussion about this. Well, discussion with myself only because I'm the only one here. But what these guys have in common is basically scale. All these things: data lake, data lakehouse, data mesh, data ops, observability, and governance. I say that they have in common scale because it's when you have a scale, when you have data at scale and use cases at scale, that these guys start to make a lot of sense. You can have a very small company or a company that doesn't have a lot of analytical ambitions, and then probably you are going to be fine without hearing about these guys until you start to become a data-driven organization, and then you will have this ambition, and then for sure you're going to be, at least these words will be crossing your eyes at some point. So the data lakehouse, what I wanted to do in this slide is also see how, or discuss how data mesh goes with these different concepts. Data lakehouse, as we will cover, we have covered in some blogs, and we will also talk about data lakehouse in other blogs from ClearPix. Data lakehouse is a simplified architecture that combines data lake and enterprise data warehouse. How this simplification and what features you ask for the data lakehouse, that's something that every vendor says a slightly different thing. Data mesh and the lakehouse, how do they compare? How do we relate to each other? Data mesh does not propose to throw away data lakes or data lakehouse or data warehouse. It just proposes to use them differently. Okay, actually, even for a data mesh, you're going to need data lakes and warehouses and data lakehouse and even more things, because due to the polyglot nature of what data mesh proposes, at least we're going to also, if we want streaming capabilities or streaming data products, we're going to require a streaming platform with Kafka or Flink or stuff that can handle streams. You may also, for some use cases, require graph databases or other NoSQL databases. So that's the data lakehouse or or data lakes or enterprise warehouse are probably some things that you're going to find anyway in a data mesh. Just use them in a different way. Data ops, which is like DevOps for data plus, with few more things, is basically a bunch of methodologies for building data solutions. And you can have data ops without data mesh. That actually are advisable also. But for sure, if you have a proper data mesh implementation, it will follow data ops. You will have agile, automated testing, CI/CD, infrastructure as code. These things are going to be there. Data governance. Also, you can have data governance without a data mesh, just with a traditional enterprise data warehouse. because data governance deal with data quality, cataloging, metadata management, security, ownership, compliance, canonical data modeling, and all these things. There is also a term that has been gaining traction in the last couple of years, which is data observability, which is kind of an extension of data governance, which adds monitoring, testing, and pretty much everything around the health of the data and the data systems that prepare this data. And that observability is also about giving the capability to get access to this observability data in an easy way. Like governance, observability is something that you can have without data mesh, and in a serious enterprise data platform, be it with data mesh or without data mesh, you will find it. But since we're talking about data mesh, a proper data mesh implementation will or should include data governance and observability capabilities. Therefore, the fourth generation enterprise data platform combines data mesh and all these things above. Okay, and I said that until now, data mesh I mentioned that it's technology agnostic, which is the case. Definition itself is agnostic, but it's just not something, it's just not a couple of book articles anymore. Tech vendors are talking, and they are in some cases even having mentions of data mesh or their reference architectures for building data mesh in their own web pages. No, for Azure, I couldn't find inside Azure documentation or Azure official blogs anything, but for example, for Cloudera or for Amazon, they have in their official blogs or in their official documentation, they have information about data mesh. Dremio also. Snowflake, even in the Snowflake web page, Snowflake goes as far as claiming or announcing or putting in the web that data mesh is the data lakehouse 2.0. It's kind of going in line with what I said. No, data mesh is data lakehouse plus other things. And in the case of Oracle, it's interesting to mention that there is an ebook that talks about enterprise data mesh in Oracle. Okay. In ClearPix, we also try to put a bit how the reference architecture of a enterprise fourth generation enterprise data platform based on data mesh looks like, and this combines all the words or aspects that I mentioned a couple of slides ago. So here you will have a data mesh with the domains, the data products. You will have the self-service layer and the data infrastructure as a platform that provides storage, compute, access control, catalog, and so on. And as part of this data infrastructure as a platform, probably you may have a data lakehouse that takes care of the data lake and the ingestion transformation engine, and also data warehouse capabilities. And you will also find things like streaming platforms, stream processing, NoSQL, and data governance and observability tools. Okay, the whole thing is going to be defined by a governance, federated computational governance body that sets standards, ensures interoperability, globalized security and compliance, define boundaries, and so on. And all the development and all the infrastructure creation ideally should happen following DataOps methodologies with automated testing, CI/CD, leveraging infrastructure as code, and so on. Okay, so data mesh, for me, it's a very interesting idea. I have been lucky to participate in an implementation recently, and I was a bit skeptical in the beginning, to be honest. But the more I learned about it and I saw it in practice, I really started to like it. It's not that I think that everyone should. I don't think everyone will go to data mesh right away, but it's a very interesting alternative that goes and tackles traditional pain points. So I think it's good that is put on the table. No, the option is put on the table, and at least then we'll see. In ClearPix, we're happy to help you if you are in that position in which you want to discuss if a data mesh is good for you, or maybe more a traditional centralized data platform that may be fine as well. So we are here to help you. Let us know if you need any guidance, and I really hope you enjoyed the webinar as much as I did. Stay tuned with our blog articles because I may want to extend a bit of what I discussed today about data mesh. And again, if you need any guidance or any help, let us know. Thank you. Have a good day.